This video is a demonstration of the PYMS suite of tools being run within the YABI framework. YABI is a web-based environment where you can create workflows consisting of chains of tools. Each tool's output can serve as the input to the next tool, and when you're happy with your design, you can have it run on whichever computing hardware you have available. We have set up a selection of tools from the PYMS suite, and today we're going to run a couple of jobs. Firstly, we need some data to work on, and I'm going to upload an extra file. This is GCMS data in the CDF file format. And now we simply upload the file from our local machine into the YABI system. Let's design our first workflow. In the left-hand side, we see the tools which are available to us. The first tool generally to use is the Select File tool. This takes a file from the available file systems and presents it to the next tool which we were about to add. We're going to select a CDF file, and because we've selected a CDF file, the tools available to us on the left-hand side are filtered to show only tools which allow an input of CDF, and you can see that in the filter that's up the top there. So let's go ahead and add the PYMS preprocess tool. This simply takes an input CDF or JDX, which we can actually see detailed here in the tool itself, and builds an intensity matrix, so it outputs an IM file. And here are the parameters for the tool. There aren't many for this one, it's quite simple. Now we can see in the tools column that the tools available to us are those which accept an input of type IM. So we might want to crop the intensity matrix, and we can add the crop tool and then add a couple of the parameters to actually do the crop. Now, since each tool instance is an isolated unit, I could go ahead and chain several crops together if I really wanted to. And you'll notice that these types of tools are taking an input of an intensity matrix and also outputting an intensity matrix. So we can chain these together in any way we like. So as the next step, we're going to add a filter, a window averaging filter, and on the right hand side we can see the default arguments. We can change these, of course, if we'd like. Next we'll add another filter, a Savitsky-Golay filter, and again we have default arguments here which we will leave alone for the time being. Now we can reorganize these units in any order we see fit. We can do one filter before the other, we can filter before we crop. They can be rearranged arbitrarily as long as the inputs and outputs match up, and we can repeat a step several times. The next thing we'll want to do is deconvolve. This will actually produce an output file, so you'll notice that in the 3 previous steps we've been dealing with intensity matrices as inputs and as outputs, so that's why we can chain all those steps together. This last step, the deconvolve, takes in an intensity matrix but outputs a PYMS peaks object file. The deconvolution function actually has a number of parameters, and if we want to get down into the details, we can show those and we can change the defaults if we want to, but we can leave those there for the moment. I've also defined an extra tool which takes an input of type PYMS peak object and will actually plot that using matplotlib. So we can add the PYMS plot peaks tool now, and we can use that to produce a PNG of the resulting graph. So now we've designed our entire workflow, and we will just give it a name so that we can run that as a job. Now we switch over to the Jobs tab, and we can see that our newly created job is running with the circular progress bar there. The other jobs there listed are previous runs that I've done of other workflows. But we can see each tool in our workflow has been loaded up for us to see, and we can watch the job actually progress through the system. The job will keep running automatically even if we log out and progress through all of these stages. So we can actually go and create a whole new workflow if we like while that one's running. I'll just create another one quickly. So this time we'll select one of the other files. And then we'll do a preprocess, a filter, and we'll deconvolve and plot the peaks. And then we can take any of those tools and adjust any of the parameters that we feel like. Now that we're happy, we name our workflow and then we can submit it as a job. So we can see that it has now also entered the jobs queue, and our previously run workflow is also there, and it is still chugging away. So I mentioned before that those jobs would continue to run automatically even if I logged out, which I can just demonstrate by logging out, and I'll log back in and we'll see if our jobs are still running. And there they are, still going. Now I can show you some of the other jobs that I've run previously. So here's one quite similar to the workflow that we designed earlier. We can see that each step has been successful, and you can actually go through each step and see exactly what its file outputs and inputs were. So this one just produced the CDF file. This one actually turned it into an intensity matrix, and you get a standard error and standard out for each tool so that you can see if there were any problems or anything you need to take a look at. And the output of the plot peaks tool, rightly enough, is a PNG of the actual data into a graph format. And I can go and have a look at one of the other workflows that we've run and see a similar graph which has just been filtered slightly differently with a different set of parameters and some slightly different filters. One very useful feature is being able to reuse previously run workflows. So if I take a workflow that I like, and I like that set, but I want to run it on maybe some different data or with some different parameters, I can just reuse it. And there it is, it just loads all those modules up, and I can select a different file as the input, and I can change any of the tool parameters that I like. The workflow is automatically named with a name similar to the one that you cloned it from, which you can obviously change if you want to. So there we are. That is a demonstration of the PYMS suite of tools running in the YABI environment.